Hello guys, welcome back to Math with Trockers. Okay, Taylor series and binomial expansion are important topics in the ZIMSEC November 2026 Specimen 6042-2 or Pure Mathematics Paper 2. In this question, we expand functions carefully and use the series to approximate a given said expression. All right, the question reads 6a. Using Taylor series, find the first 5 terms of the function f of x equal to x minus 2 by e to the 2x near x equal to 2. B, given that y equal to 1 over square root of 1 plus 5x plus square root of 1 plus 2x, where x is greater than negative 1 over 5 and x is not equal to 0, show that y equal to 1 over 3x times square root of 1 plus 5x minus square root of 1 plus 2x. C, item 1, using the form y equal to 1 over 3x by square root of 1 plus 5x minus square root of 1 plus 2x, express y as a series in ascending powers of x up to and including the term in x squared. 2, hence, by putting x equal to 1 over 25, show that 5 over square root of 30 plus square root of 27 is approximately equal to 4689 over 10,000. Okay, guys, let's get the ball rolling. Okay, so we have the function, this is 6a. We have the function f of x equal to x minus 2 e to the 2x near x. So we need to use the Taylor series to find the first 5 terms of the function f of x equal to that near x equal to 2. All right, so let's go ahead and find the derivatives here. So we need to differentiate. Okay, so first derivative, right? First derivative is equal to, so that's my u and v, right? So it's u, which is x minus 2, dv is going to be 2 e to the 2x plus v e to the 2x du is just 1. So here it's 2x minus 2 e to the 2x plus e to the 2x, which is equal to 2x minus e to the 2x, right? Okay, sorry, this is supposed to be 2x e to the 2x, right? E to the 2x, because if we expand here, okay, sorry, let me do it this way. Okay, let me do it this way. Okay, so it's going to be, okay, I have u dv plus v du. So if I expand, it's 2x e to the 2x, this and that, minus 4 e to the 2x plus e to the 2x, right? Okay, which is equal to 2x e to the 2x minus 4 plus that is minus 3 e to the 2x. Then I'll take out 2x minus 3, so I'll take out e to the 2x, right? Okay, then allow me just to evaluate here at 2. So f at 2 is going to be 0 here, right? F of 2 is going to be 0, right? Because it's 2 minus 2. Okay, then what do we need? Okay, so we also need f prime prime. So the second derivative here, let me evaluate f prime at 2. So f prime at 2, 2 times 2, that's 4 minus 3, that's 1. Then e to the the fourth power is just e to the fourth power, right? Okay, then so now we are looking for the second derivative. Sorry. Okay, second derivative, right? U dv, so it's going to be 2x minus 3 dv is 2 e to the 2x plus v. Then if we differentiate here, we get 2. So it's going to be 4x e to the 2x minus 6 e to the 2x plus 2 e to the 2x, which is equal to 4x e to the 2x minus 4 e to the 2x. Then we have 4x minus 4 e to the 2x. Let me evaluate f prime prime at 2. Let me evaluate f prime prime at 2, which is equal to 4 times 2, that's 8, minus 4, that's 4 e to the 2x, right? So 4 times 2, that's 8 minus 4, that's 4, then e to the 4th power, right? Or let me, okay. So it's 4 e to the 4th power. Now we move on to the third derivative, right? So the third derivative, we are doing the same thing. It's u dv plus v du. So that's 8, 2 times 4, that's 8x e to the 2x minus 8 e to the 2x plus 4 e to the 2x. So I'm getting 8x e to the 2x minus 4 e to the 2x, right? Which is equal to 8x minus 4 e to the 2x, right? Then let's evaluate f prime prime at 0. So 8 times 2, that's 16, minus 4, that's 12, right? E to the 4th power, okay? Now, let's move on to the fourth derivative. Fourth derivative, f prime 4, all right? Fourth derivative, we're going to do the same thing. It's going to be 8x minus 4 e to the 2x plus 8 e to the 2x. Then this is 16x e to the 2x minus 8 e to the 2x plus 8e, okay, plus 8e to the 2x. And we have this and that cancels out, so we only have 16x e to the 2x. And now if you evaluate f fourth derivative at 2, right, it's going to be 32, right, e to the 4th, okay? Then lastly, since we need the first 5, let me end here, okay? So f4 of x, right, the fifth derivative, I mean, is going to be v 16x, okay, so that's u, that's v. So this is going to be v du times 2, right, e to the 2x, right, plus 16 e to the 2x, which is equal to 32x e to the 2x plus 16 e to the 2x. So if we evaluate the fifth derivative at 2, right, it's going to be 64. Okay, here it's like we have it's like we have 32x plus 16 e to the 2x, right? So this is going to be 64 plus that, is it not 80? Okay, so 32 times 2, that's 64, plus 16, right? That's 52. Okay, so this is 52 e to the 52 e to the fourth power, right? And when we get that part now, let's go ahead and write the formula which you want to use, right? So here we know that f of x, so our formula f of x is going to be f of 2 plus f prime at 2 x minus 2 plus f prime prime at 2 x minus 2 squared over 2 factorial plus f prime prime at 2 x minus 2 cubed over 3 factorial plus fourth derivative at 2 x minus 2 to the fourth over 4 factorial plus f prime at 2, fifth derivative at 2, then x minus 2 to the fifth over 5 factorial, right? So remember guys, we need this, right? Let me write them here. f2 equal to, right, I have f prime at 1 plus equal to f prime prime at, these are 2, at 2, right? Then we have f third, then we have the fourth derivative, and we have the fifth derivative at 2, so that we can just plug them into the formula. So here we have 52 e to the fourth, right? So this is 52 e to the fourth, right? Okay, I have 52, I have 32, I have 12. Okay, so here I have 32, I have 12, right? What about second and first derivative? All right, second and first derivative, so that's 4 and e and 0. Okay, 0, 4 and e. Okay, so I have 0 e to the fourth and 4 e to the fourth, right? So now 1, 2, 3, 4, 5 terms. Okay, so if we plug in into the formula, so now this implies that function of x, remember this one here, remember this part is 0, so it's going to be 0 plus e to the fourth, right, times x minus 2 plus this one 4 e to the fourth, right, x minus 2 squared over 2 times 1, then plus the third, it's 12, so it's 12 e to the fourth x minus 2 cubed over 3 times 2 times 1, right? Then plus, right, this one, f fourth. From there, we have 32 e to the fourth x minus 2 to the fourth over 4 times 3 times 2 times 1 plus 52 e to the fourth x minus 2 to the fifth over this is 5 times 4 times 3 times 2 times 1. All right, so guys, let's verify something. Let's verify something here, guys. Let's see. All right, we were here, right? 16x e to the 2x, right? That's okay. Okay, let me come back here. All right, so I have u dv, right? I'll bring this down, plus v du. So when I expand 2 times 8, that's 16. Negative 8 plus 8, okay, they cancel out. So here it's going to be u, right? 16x, okay, let me see. So that's my u, that's my v. So u dv is 2e to the x plus, I see, it's supposed to be plus this, okay, plus v du, it's 16, correct? All right, so if we expand here, we get 2 times 16, that's 32, right? 2 times 16, that's 32x e to the 2x plus 16, right? So here, I think that's where we went wrong, because it's supposed to be 32 times 2, that's 64 plus 16, all right? So 64 plus 16, oh, that's 80, right? So it's gonna change this into an 80. So this one here is, it's going to be 80, sorry. Okay, so this is 80. Okay, no problem. So let's go ahead and just change here. All right, so here we, instead of 52, we have 80, right? Okay, no problem. Then we also have to change this part. We need to change this part into an 80. So when I say 80 divided by 5 factorial, I'll get 2/3. All right, oh, that's good. So that's an 80. Okay, so now let's go ahead and simplify. So if we go ahead and simplify, we have f of x equal to, this is 0. So this is now e to the 4th x minus 2 plus this into that. That's 2 e to the 4th x minus 2 squared plus 3 times 2, 6 into 12. That's 2 e to the 4th x minus 2 cubed plus, okay, 4 times 3, 12, 24. Okay, 32 divided by 4, 3, 2. So 32 divided by 4 times 3 times 2, 24. Okay, I'm getting 4 over 3. So plus 4 over 3 x minus 2 to the 4th. Okay, I omitted something here. Okay, it's 4 over 3 e to the 4th of x minus 2 to the 4th plus 80 divided by 5 factorial. That's 2 over 3. So 2 over 3 e to the 4th of x minus 2 to the 5th. And that's all, guys. This is the expansion. The first 5 terms of the function f of x, x minus 2 e to the 2x, near x equal to 2. So that's the Taylor series expansion for that particular function. So now we are moving on to the next question. Okay, so on item B, right, we are given this function y equal to 1 over square root of 1 plus 5x plus square root of 1 plus 2x, right? And we need to show that, right? So we need to show that y equal to 1 over 3x square root of 1 plus 5x minus square root of 1 plus 2x, right? Okay, So guys, whenever we are dealing with sets, especially if they appear in the denominator, let's go ahead and rationalize. So y equal to 1, right? So here it's going to be square root of 1 plus 5x minus square root of 1 plus 2x, right? Over, this is going to be 1 plus 5x plus 1 plus 2x, right? Then 1 plus 5x minus 1 plus 2x, right? So remember guys, a minus b, a plus b is identical to a squared minus b squared, right? So here it is y equal to square root of 1 plus 5x minus square root of 1 plus 2x over, so it's just going to be square root of 1 plus 5x squared minus square root of 1 plus 2x squared, right? Which is equal to square root of 1 plus 5x minus square root of 1 plus 2x over, here we have 1 plus 5x minus 1 minus 2x, which is just square root of 1 plus 5x minus square root of 1 plus 2x over, this and that cancels out, so over 3x. So therefore y equal to 1 over 3x square root of 1 plus 5x minus square root of 1 plus 2x, right? So we are done here. Okay, so now we move on to C item 1. So on C item 1, it's saying using the expression, so we want to use y equal to 1 over 3x, right? Square root of 1 plus 5x minus square root of 1 plus 5x, right? So we need to express y as a series in ascending powers of x up to and including the term in x squared. Okay, so guys, let's not stress, right? Don't stress at all. One thing that you need to know is that if we have 1 plus u, right? Sorry, this one here is 2. Oh, let me do it nicely. Okay, 1 plus 2x. Okay, so when we have this, right, it is the same as 1 plus u, right, to the 1/2. So we are going to expand using 1 plus b to the n power, which is 1 plus nb plus n minus 1 b squared over 2 factorial. So here we are going to stop at b cubed, because according to the question, we are supposed to expand up to the term in x squared, but remember, we will divide by x. So if we expand up to x cubed, when we divide by x, we come back to x squared, right? So let's go ahead and expand this, right? So here it is going to be 1 plus n b plus n minus 1, right? B, okay, so I need to move this. Okay, let me do it here. All right, let me just do it at the bottom. So 1 plus u to the 1/2, right? Okay, allow me to get rid of this. All right, so 1 plus u to the 1/2, right, is equal to 1 plus nb plus n minus 1 b, which is u squared over 2 factorial plus n minus 1 n minus 2, which is minus 3 over 2, because 1/2, right, subtracting 2 That's minus 3 over 2 over 3 times 2 times 1. And then here it's u cubed, right? So it is just 1 plus 1/2 of u, right? So this and that is 4. So minus 1 over 8 u squared. Then this and that it's 6. This and that it's 4, right? This and that it's 2. Okay, no problem. So we have negative, negative. So plus this and that is 2. So plus 1 over, so 2 times, let me see. Okay, so this is 4, right? So that's 4. That's 2, 8 times 2. That's 16 u cubed. Right, let me verify for the last time. Okay, so this 3 into, okay, this 3 and that 3 cancel out. Then 2, that's 4, right? So 2 times 4, that's 8 times 2, that's 16. Okay, then that's a positive. All right, so this is exactly what we have here. Right, now the reason why I expanded in terms of u, right? Remember, u was just square root of 1 plus u, right? Now, coming back to our case, we have square root of 1 plus 5x. So we're just going to replace u with 5x. So it's going to be 1 plus 1 over 2 5x minus 1 over 8 5x squared plus 1 over 16 5x cubed. So here it's 1 plus 5 over 2x minus 25 over 8x squared plus 125 over 16x cubed. So we are done with this. Then we do the same for square root of 1 plus 2x. So for square root of 1 plus 2x, we just say 1 plus 1/2, then we put 2x, right, minus 1 over 8 2x squared plus 1 over 16 2x cubed, right? And now if we expand, we have 1 plus x, right, 4 over 2, 4 over 8 minus 1 over 2x squared, 8 over 2 plus 1 over 2x cubed, right? We are done. So now let's go ahead and write that series, right? So remember, y equal to 1 over 3x, right? It was square root of 1 plus 5x minus square root of 1 plus 2x, right? So it's simply 1 over 3x, right? So square root of 1 plus 5x is this one, that one. So it's 1 plus 5 over 2x minus 25 over 8x squared plus 125 over 16x cubed, right? This subtracting, right? This one, 1 plus x minus 1/2 x squared plus 1/2 x cubed, right? Okay. All right. So we had this, we had that. Okay. So we have 1 over 3x, 1 subtracting 1, it cancels out. Then 5 over 2 minus x, that's 3 over 2, I think. 5 over 2 minus 1, so we have 3 over 2x, right? 3 over 2x, then negative 25 over 8, so negative 25 over 8, negative 25, okay, negative 25 over 8, subtracting that, so plus 1 over 2, I'm getting negative 21 over 6, so minus 21 over 6, right? Minus 21 over, sorry, minus 21 over 8, not 6, minus 21 over 8 x squared, right? Then lastly, we have that 125 over 16, right? Subtracting 1 over 2. I'm getting 117 over 16, right? So it's plus 117 over 16, right? X cubed, right? Now let's divide here. So if I multiply this by 3, 3 and 3 will cancel x and x, so I will have 1 over 2. Then 3 into 21 here, that's 7, so I will have minus 7 over 8 x, right? Then that and that, so I know I will have x squared. So what is 1 over 3 times 117 over 16? I have 39 over 16. So I have plus 39 over 16. Sorry. It's plus 39. Okay, so plus 39 over 16x squared. And that's the expansion. Right. Okay, so now let's move on to the last part. So the last part, hence we are going to use the result obtained above. So see item 2, by putting x equal to 25, 1 over 25. So let x equal to 1 over 25. Show that 5 over square root of 30 plus square root of 27 is approximately equal to 4689 over 10,000. All right, so guys, remember, right? So now, remember this part here, right, is equal to 1 over 2 minus 7 over 8x plus 39 over 16 x squared, right? The expression was 1 over 3x, right? No, let's not use 1 over 3x, but let's use the other one. Let's use the other one, right? Okay, so we have it was y equal to that was 1 over 1 plus 5x plus square root of 1 plus 5x plus square root of 1 plus 2x. So let's deal with the left hand side first, right? So dealing with the left hand side, we have 1 over square root of 1 plus, remember it's 1 over 25, so it's 5 over 25 plus square root of 1 plus 2 over 25, right? So which is equal to 1 over, so 1 plus 5 over 25, it's 6 over 5, so it's root of 6 over 5, right? That's root of 25, 30 over 25, okay, no problem. Okay, let's not simplify it because we'll always come back here. All right, so 25 plus 5, that's 30. So we have got 30 over 25 plus square root of 27 over 25. And this one here is 1 over root of 30 plus root of 27 all over root of 25 here, it's 5. So if I keep change flip, right, I will get 5 over root of 30 plus root of 27, right, which is this left side. So now let's go ahead and plug into that series. So y equal to, remember it's 1 over 2 minus 7 over 8x plus 39 over 16 x squared. That's the right hand side. So now y equal to 1 over 2 minus 7 over 8, 1 over 25 plus 39 over 16, 1 over 25 squared. And let's see what we get. So I have 1 over 2 minus 7 over 8, 1 over 25, right? Plus 39 over 16, right? 1 over 25 squared. Okay, so I'm getting 4689 over 10,000, right? So therefore we have 5 over square root of 30 plus square root of 27 is approximately equal to 4689 over 10,000, right? Okay, guys, that's all about this problem. Practice more expansion questions to improve your accuracy, confidence, and examination technique. I will see you in the next one. Take care.